Welcome to Humans in History, the part of the show where we take a moment to remember and ponder just how humans have adapted to this tiny blue marble we call Earth. Today, we're looking at humans' quest to reach out away from this world.
That's right, Lisa. Since the days of the cavemen, we humans have always looked to the heavens and dreamed of going there. Finally, in the 20th century, we've developed rockets strong enough to take us there.
Right you are, Rhonda. Our first stop is the Apollo Exploration Program, first endorsed by President Kennedy in the 1960s. Its premier purpose was exploring that chunk of rock closest to us, our very own moon.
Indeed. NASA designed the Apollo Command Module for this program. It was a capsule with room for 3 astronauts. The astronauts rode the command module on the way to the moon and back. The crew area had about as much room as the inside of a car.
That must have been cramped. Good thing they were able at last to get out and take a walk on the moon. On July 20th, 1969, 2 astronauts, Buzz
Aldrin.
I'll never be able to say that. Buzz Aldrin and Neil Armstrong became the first humans to walk on the moon.
And it was quite a leap indeed. These missions made it possible to explore more distant worlds further in the future.
Which brings us to the next rung on the great ladder of launching humans into space, the Space Shuttle program, begun in 1981. This spacecraft allowed 7 astronauts to travel in a living space as large as a van. Finally, humans operated reusable spacecraft.
And those reusable shuttles led to a number of civilian and military advances, including the use of satellites for both military advantages during the Gulf War of the 1990s, and adding a number of television channels to non-astronaut humans back on Earth. Satellites were used to track weather and monitor forest fires as well.
24 successful shuttle launches fulfilled many scientific and military requirements until January 28, 1986, when just 73 seconds after liftoff, the Space Challenger exploded. The crew of 7 was killed, including a teacher from New Hampshire who would have been the first civilian in space.
A grave day in the history of humans in space, indeed. 23 years later, the Columbia disaster was the second shuttle tragedy. On February 1st, 2003, the shuttle broke apart while re-entering Earth's atmosphere, killing all 7 crew members.
Despite these tragedies, the Space Shuttle program set the groundwork for humans' next great space program, the International Space Station.
The International Space Station has been continuously occupied since the arrival of Expedition 1 in November of 2000. Astronauts from different countries live there in groups of about 6 for about 6 months at a time. Their job is to conduct scientific research that only a microgravity environment can provide as they orbit the Earth.
Whether hard at work maintaining the instruments or conducting experiments, these astronauts have to always account for living in microgravity. They use rinseless shampoo and have to strap themselves down to use the bathroom. They sleep in sleeping bags, strapped to their bed.
Imagine that.
Yes, and while the ISS has performed tons of important gravity and medical research over the years, as they say, nothing lasts forever.
That's right, Lisa. As we speak, NASA and its international partners are putting the finishing touches on humanity's new home in space. The new Lunar Space Station will be a fraction of the size of the ISS, but will carry astronauts hundreds of thousands of miles farther into space. In fact, it might travel farther away from our planet than any other human-piloted spacecraft, including the Apollo missions.
If everything goes as planned, the first mission will launch in 2023 and position a robotic spacecraft called the Power and Propulsion Base, PPB, in a stretched orbit around the moon. Then, in the next 2 years, a pair of barrel-shaped modules 4.5 meters wide and 5 meters long, and both weighing under 10 tons each, will be delivered to the same orbit as PPB.
On the inside, everything will be meticulously designed to save mass and maximize room. The dining tables will fold after each meal, and the sleeping compartments will inflate and deflate as needed. the fridge will have to multitask as a kitchen appliance and scientific sample storage. Huge efforts will be made to recycle and reuse every drop of water, oxygen, and other consumable resources on board.
The ultimate goal for this new project will be a deep space expedition lasting more than a year, a dress rehearsal of sorts for a future mission to Mars.
In the future, this lunar space station might serve as a parking hub for robotic and later human landers returning from the surface of the moon.
The possibilities are truly endless.
Indeed. Mars, here we come.
You know, I've always wanted to eat a Mars bar on Mars. And that's all for our look at the history of humans.
Thank you for joining us.
What you will see next is you will hear from several folks that are on the Lunar Space Station, as they're going to be talking about how they created a government and what they brought from home.
Thank you for meeting with us, Commander Hunt. Can you tell us a little bit about the type of government you've created here on the Lunar Orbiting Space Station?
Why, yes. When we came up here to the Lunar Orbiting Space Station, we decided that we wanted to keep very similar to what we had on Earth. So since most of us are part of NASA, we decided to keep the idea of a representative democracy, much like the United States. We like the idea of everybody having a voice in what happens in the government.
That's interesting. Can you tell me a little bit about the branches of government that you have established here?
Well, we have 4 branches of government, unlike what we're used to on Earth. Some of them are quite similar. We have an executive council, which makes all of the decisions. So 3 members are elected to that every 4 to 6 years, depending upon the position. We have a legislative group, kind of similar to Greece, what they had back in the day. A percentage of the population is represented on this legislative group. And much like the Congress of the United States, they take care of most of the laws. We also have a judicial branch, which we refer to as the 5 elders. Except they're not necessarily the oldest people. They are just the ones that have had the most experience here in space. We discovered that as we spent time up here, if you've not been in space, it's kind of hard to tell people what to do. So to us, it made sense that these would be the folks to have judgment on the law. Is it a good law or not? And they have the most experience here anyway. So why not let them make judgments on when people break the laws? Our 4th branch, which you don't have on Earth, is our scientific branch. So while we're up here around the moon, we're trying to figure out, can humans live in space and how do we explore the rest of the solar system? And since that's such an important job, we thought they should have their own branch of government.
So, can anyone be a part of the government, or are there qualifications?
I'm glad you asked. One of the first things that we did when we got up here is just anybody that needed to be in the government could. We had a limited number of folks. But as more people came up to the lunar orbiting space station, we started having the qualification that in order to be part of the government, you needed to have at least 5 years in space. Again, it's a completely different environment than what it is on Earth. So those folks with the best experience really makes up for the best governors. We also wanted to have people that were well respected. So in order to even run for a position of the government, your name has to be submitted by someone else. It's not that you wake up one morning and you just want to be the president, so to speak. So also, we put some other requirements on officials. We wanted to make sure that the people that were elected not only knew what they were doing, but they didn't buy their position. So one of the limitations that we put on officials was that they could only spend $50,000 on campaigning. And that's money that comes either from their pocket or any gift that somebody may have given them.
What about the rights and responsibilities of citizens up here?
Well, again, unlike Earth, where some folks decide they just don't want to vote, we don't really have that option up here. We're running on a limited number of people. Everybody's job is important, and everybody's opinion is important. So one of the first responsibilities is that all citizens must vote. There are no exceptions. If you're going to be part of the Lunar Orbiting Space Station, voting is your responsibility. We also talk about how everyone has to work. Unemployment is not anything that we can handle up here. Everybody is going to take up resources, and we need to make sure those resources are used wisely. Also, just like on Earth, we're going to pay taxes. And so that helps run the government, helps them make the decisions that they need to make. The government's tax, though, is 10% flat. So no matter how much you make, it's always going to be the same amount of money. As far as the rights are concerned, being part of an international group of folks that brought us up here to the International Space Station, we adopted the United Nations Declaration of Human Rights and follow it exclusively.
Well, thank you for your time. Now we are going to do a little reporting about what life is like up here on the Lunar Orbiting Space Station.
Here we are with mission specialist Aiden Allen. When we spoke to the astronauts about life up here on the Lunar Space Station, they talked about the pieces of culture that they brought with them from Earth. Here, Mr. Aiden Allen is going to talk to us a little bit about one of those things.
What we decided that we needed was really important was entertainment, because we all have to have something to do. We have a gaming console so we can play games against each other, play online, whatever. We've got movies to watch, enjoy, some old TV shows, and then books for whenever the Wi-Fi goes down. So we have a whole phone.
We asked astronaut Cora Riley what she would bring with her from Earth culturally, and her answer was
Food. Like Chick-fil-A, Subway, Bojangles, all of it.
one of the more interesting things that we've heard about culturally this week have been the invention of these magnetic gloves. Astronauts have been using these out on spacewalks for months. On Earth, we don't ever think about floating away, but in space, you always have to make sure you're in contact with something like this grate here. We spoke to one of the maintenance crewmen earlier this week, and we got a great quote from him. They say in space, no one can ever hear you scream. That is true. With these gloves, I have not dropped a hammer on my toe in months.
Two, one.
Thank you, Ned, for that update on traffic and weather. Now back to Ted at the NASA Research Center.
Thanks, Cosmos. I'm here with Dr. Tallulah Starburst, a physiologist and nutritionist with NASA. Hello, Dr. Starburst.
Hello, how are you?
It's surely nice to meet you.
Oh, I'm so glad to see
Well,
you.
Dr. Starburst, what are you working on now?
We are working on healthy recipes for our astronauts at the International Space Station, and currently I am making one of these famous recipes right behind me. So let me go ahead and tell you what we have. We have quick oats, we have some chocolate, we have dried cranberries, a little bit of salt, some peanut butter, and some honey. So you may be wondering, what on earth is she making? Well, we are making International Space Station bars. So you will use 1/2 cup of granola. You'll use a 1/4 cup of the honey, as many of these as you see fit to put in there. You'll use a 1/2 cup of peanut butter. And then, again, as much chocolate as you would like. So, because we are on such a limited time schedule, typically you would refrigerate this. I've already made a batch and it's refrigerated, but now I've decided to heat it up. So, I cannot wait. Are you ready?
Well, that looks delicious, Dr.
Look how
Starburst.
cool it is!
May I try a bite?
I would love for you to try a bite. That's hot.
Oh. Gee. Oh, that's amazing. That's amazing. And our spacemen get to eat that.
Yes, they do. This is just one of the meals that we prepare here on Earth to send up to them. And also, I don't know if you realize this, but what you're eating is a mixture. Have you heard about that before?
Why is that important?
Well, it's important because it is only altered physically. So when we combine all the ingredients, there are no chemical changes going on. So if we wanted to, we could separate everything back out and we could get what we started with. However, if there were a chemical change, there could be loss of weight, or there could be gases expelled, whatever. But this is a mixture, and so this is one of the easiest things that we can send to our astronauts. 2, 1.
Thank you, Ned, for that update on traffic and weather. Now back to Ted at the NASA Research Center.
I want to say thank you to Dr. Starburst. She had to go back. She's in the middle of an experiment. We have her assistant, Ellen Sunshine, here. Ellen, is that dried cranberries?
Yes, they are, Ted. Let me show you our dehydrator and why dehydrated food is important. I have a handful of cranberries here. What we're gonna do is we zero out this. We are going to weigh them and place the weight within our spreadsheet for our math portion of knowing how to do that. When we started with 10 grams and we ended up with 4 grams, we created a 60% reduction in mass and the corresponding reduction in volume with no loss of nutrition. This makes the transport and the storage much, much easier. So if you would like to see what our final product looks like, there you go.
Well, thank you.
You're welcome. I hope you enjoy it.
This is Ted Steele from NASA Research Center. Back to you, Cosmo.
2, 1.
Thank you, Ned, for that update on traffic and weather. Now back to Ted at the NASA Research Center.
Well, Ted, we do not eat to fill our stomachs. We eat so our digestive system can break down our food chemically to the point that our cells can use it. Just like our respiratory system is not filling our lungs just to put oxygen in our lungs. It is so that our lungs can break it down to tiny oxygen molecules that our cells can use along with the sugar from our digestive system to create energy. Energy our body needs for physical activity, mental activity, and autonomous activity. The cardiovascular system, which we need to keep at a peak, is the vehicle to deliver the sugar and oxygen to our cells. While I have you, Ted, let me tell you that the organelle in your cells that produces energy is your mitochondria. Hey, Ted, are you up on your organelles?
Well, let me see. Is the nucleus the brain of the cell?
Yes, Ted, I will let you stop at that.
Thanks, Ellen. This is a fascinating place. Back to you, Cosmos.
And now we will go live to Astra M. Law at the International Space Station for a look into exercising in space.
All right, thanks, Cosmo. Welcome everyone to a sneak peek into the International Space Station exercise room. Take a look at what's going on back here. No, they're not getting ready to go bungee jumping. These astronauts actually have to use bungees in their exercises because there's no gravity here. Gravity, though we can't really feel, is always at work on Earth. It's constantly pushing down on us, our bones and our muscles, and it's the reason our blood is constantly flowing. When astronauts enter the zero-gravity environment of space, however, there's no constant push on their muscular, skeletal, and cardiovascular system. This can cause huge problems for astronauts here in space and takes much effort and planning to overcome in order to keep a healthy body system. Because of this, exercise is really important. On Earth, the Department of Health and Human Services recommends we spend about 150 minutes on exercise, or roughly 30 minutes as exercise per day for 6 days. Astronauts, however, typically work out for a minimum of 2.5 hours of each day, 6 to 7 days a week. Even still, many astronauts return to Earth with muscular atrophy, bone density loss, and long-term cardiovascular health issues. Come with me real quick and we'll talk to a few of our resident astronauts about why exercise is so important here. Here is Luna Ray Walker now. Hey Luna, can you tell us why it's so important that you spend so much time running on this treadmill per day?
Hey, Astra. Well, on Earth, gravity is constantly pushing blood from your heart all the way down to your legs. But it has to work hard to pump your blood to your head and everything else above your chest. But in space, all your blood kind of sort of floats around. Because of this, your heart doesn't have to work hard and gets a break while in space. This can cause huge problems when you get back to Earth because the long period of inactivity weakens and can even change the shape of our heart. We have to work out so hard to keep our hearts in shape, so when we return to Earth, it works properly.
Wow, thanks Luna. I might just take an extra hour run after dinner tonight. Oh, and here's Tyler Stronghold. Let's see if he can tell us something about these weight machines. Hey Tyler, can you tell us why these bungee cords are so important and why you do so many hours of workout per day?
Hey, Astro. Sure. These bungee cords are used in almost all of our machines. See, without gravity, weightlifting doesn't do anything to strengthen our muscles. Everything is going to float up anyway. But when we use these bungee cords, and this machine has the help of a special type of vacuum to add resistance, we can get the feeling of weightlifting on Earth, even in zero gravity.
Wow, I can see how that helps, but why for so long? Are you worried about your heart too?
Well, I do spend a lot of time training my heart, but right now I'm just working on my muscles. Without gravity constantly putting pressure on our bodies, our bones and our muscles quickly weaken. It takes almost no strength for me to move around, and all the muscles in activity can lead to our muscle deteriorating. That's called atrophy. Even this just happens a little bit, it can cause big problems on Earth. Astronauts may return to Earth and hurt themselves doing seamlessly easy tasks, even those that were a breeze before we left. That's why when I get back home to Earth, I still will have a strength training regimen for a month or two so I can get back in shape.
Oh, is it just our muscles you have to worry about weakening in space?
Oh no, not just our muscles, but our bones too. When we aren't moving around and using all them all the time, our bones will start to weaken too. That's why it's so important we exercise and are trying to keep them active. Eating a healthy diet with 8 vitamins and minerals can help too. Just like our muscles, if we aren't careful, we can go back to Earth and get seriously hurt. A quick jog around the neighborhood or just a small trip can easily break bones.
Wow, I didn't realize exercising way up here would have such a big effect as it does on Earth. In fact, I'm gonna go do some more exercises right now. Well, thanks for joining us at the International Space Station as we take a look at exercising in space. Until next time, I'm Astronaut.